Okay, so the next question that we have is another hyperbola, which is 49y squared minus 16x squared is equal to 784. So if you divide by 784, you get 49 divided by 784 times y squared minus 16 by 784 times x squared is equal to 1. Now to simplify this, we need to know what 784 is. So 784 is actually 2 times, well, that's 350, 700 is 350, that's 40, and that's 2, that's 392. 392 is 2 times 150 plus 45 plus 1, which is equal to 196. 196. And 196 is 2 times basically 50, 45, and 3, so that's 98. 2 times 98, and that is 2 times 45 plus 4 is 49. And well, that is of course 7 times 7. Now I know that there is a factor of 49 in 784. And there is of course a factor of 16 in there. So you can simply simplify your equation once you know your numbers. So then basically 49 by, basically if you write 49 by 784, that is basically 7 squared over 2 raised to the power 4 times 7 squared, and then that is 1 over 2 raised to the power 4, which is basically 1 over 16. So that is y squared over 16. And if you write 16 over 784, that is 2 raised to the power 4 over 2 raised to the power 4 times 7 raised to the power 2, and that is 1 over 49. So that is basically x squared over 49 is equal to 1. So now our equation is in the form of an equation y squared over a squared minus x squared over b squared is equal to 1. And so that means that basically the foci and vertices are along the y-axis. Along the y-axis. And so if I basically compare these two equations, I'll get a squared is equal to 16. That means that basically a is equal to 4, and b squared is equal to 49, which means that b is equal to 7. And that brings us to c, which basically that b is equal to the square root of c squared minus a squared. So b squared is equal to c squared minus a squared, so that means that c squared is equal to a squared plus b squared. Which means that c squared is equal to 16 plus 49, which is the same thing as 65. So c squared is equal to 65, and so c is equal to the square root of 65. And let's suppose 65 is one of those numbers that, of course, it's 5 times 65 divided by 5 is equal to 1 times 5 is equal to 15. 5 times 13. That's 5 times 13. Now, in order to find the foci and the vertices and everything else, your vertices are basically along the y-axis. So that means that x is equal to 0, and this is at a distance at a distance a from the center. That means that a and v2 would be basically would be 0 comma negative a. So this would be basically 0 comma a, which is equal to 4, and this would be 0 comma negative 4. Your foci would be f1 at 0 comma c, and f2 would be at 0 comma negative c. So this would be 0 comma square root of 65, and this would be 0 comma negative square root of 65. And then your eccentricity is equal to c by a, which is equal to square root of 65 fourths. Square root of 65 fourths. And the length of the lattice rectum, is equal to 2b squared over a, which is equal to 2 times 49 over 4. So that's 49 halves. 49 halves units. So these are basically all the information that we needed over here. Number 6. The foci are at these 2 points. Plus or minus 4, square root of 65 fourths, and 49 halves. That is correct. Okay, so the next thing that we have over here is question number 7, and here what we want to do is that we want to find the equation of the hyperbola satisfying, for example, these conditions. For example, you know that the vertices are at plus or minus 2 comma 0, and the foci are at plus or minus 3 comma 0. So you see that the y-coordinate of all of these points are 0. That means that these points are along the x-axis. Being along the x-axis, meaning that the transverse axis of the transverse axis of this hyperbola is along the x-axis. And so based on that, I can say that x squared by a squared minus y squared by b squared is equal to 1. So now in order to write the equation, I need a and b. So I know that based on this, I know that a is equal to 2 and c is equal to 3. Because the focus is at a distance c from the center, and the vertex is at a distance 2 from the center. Based on this, I can calculate my b, which is basically b is equal to the square root of c squared minus a squared. So b is equal to the square root of c squared 9 minus 4, which is equal to the square root of 5. So your b is equal to square root of 5, so your b squared is equal to 5. So now I can write basically x squared over a squared over 4 minus y squared over b squared, which is equal to 5, is equal to 1, and that is the equation of your hyperbola. I suppose they have simplified this, meaning that number 7, this is exactly they have written it as well, so we don't have to simplify anything really. Okay, so now we have a couple of, so for example question number 9 is again the same thing, so I'm not going to do that. But for example, question number 10 is the foci are at these 2 points and the transverse axis is of length 8. So this is something interesting. We could learn something with this. So the foci are at plus or minus 5, 0, and the transverse axis, the transverse axis is the length of the transverse axis is 8. So basically, if you have your foci at plus or minus 5, 0, then so we need to recall a couple of things here. So first of all, you see that your foci are 5 units apart each. Basically, you have, suppose that you have your foci at just an assumption, I don't really know at this point, but let's assume that the foci are 5 units apart, meaning that this is positive 5 and this is, for example, negative 5. This is f1 and this is f2. So then this distance over here would be 10 units. And we said that the length of the transverse axis is 8. And the length of the transverse axis is 8. So now we need to recall some definition that we had before, which basically what is actually the length of the transverse axis. I suppose it's the distance between the vertices, if I'm not wrong. So if I go back over here, and over here, the length of the transverse axis. So we said that we denote the distance between the two foci, the distance between we said that we denote the distance between the two foci as 2c. This is equal to 2c. And the distance between the two vertices, so suppose that, for example, I have these two vertices over here. The distance between the two vertices, or the length of the transverse axis by 2a. So this distance over here is actually 2a, and that is the length of the transverse axis. Transverse axis. So what that means is that if 2a is equal to 8 units, that means that your a is equal to 4. And your c is equal to, from here you know that your c is equal to 5. And one more piece of information that I have is that my focus is along the y-coordinate of this point is 0. The y-coordinate is 0, that means that this point is along the x-axis. Which in turn means that the transverse axis, TA or transverse axis, is along the x-axis. So now I have enough information to basically write the equation of this hyperbola, meaning that since basically the transverse axis is along the x-axis, I can write x squared by a squared plus y squared by b squared is equal to 1. I know my a is equal to 4, and then I can calculate my b as well, as b is equal to the square root of c squared minus a squared. c squared minus a squared, which is equal to the square root of 25 minus 16. 25 minus 16 is equal to 9, so that's the square root of 9, which is equal to 3. So my b is equal to 3. So b is equal to 3. Now so I can write basically x squared over a squared, which is 16. And this is supposed to be a negative sign. This is supposed to be a negative sign, minus y squared over b squared, which is 9, is equal to 1. And that is the equation of your hyperbola. So this was question number, I suppose number 10. X squared by 16 minus y squared by 9 is equal to 1. Now let's do question number 11 as well. That seems to be also something interesting. So we have our foci at plus or minus 3 times the square root of 5, comma 0. And basically number 11 is this thing over here. No, this is the next question. So number 11 is your foci are at 0, comma plus or minus 13. And the conjugate axis is of length. The conjugate axis is of length 24. So the length of the conjugate axis is actually so basically if I have my suppose that the transverse axis is along the x-axis, so I would have basically something like this over here. So these are my vertices, and this distance would then be 2a, which is also the length of the transverse axis. So that is 2a, and you have basically these 2 points over here, f1 and f2, and this distance over here is basically 2c, which is basically the distance between the two foci. Now there is something else over here, and that is basically some definition. Let's say if I draw a line over here, and if I draw a line over here, I will have basically these two lines, and from this point, of course I'm not really completely sure that that is the case. Let me first look it up before I give you wrong information. The length of the transverse axis by 2a, and 2b is the length of the conjugate axis. Okay, that was actually what I thought was actually correct. So if you basically from this point, if this line is perpendicular to the x-axis and it meets this line at this point, and from this point if you draw perpendicular to the y-axis, this length over here is called b. For whatever reason, I don't really know how, or basically it would actually be interesting to think about this, but I just never happened to think about the relationship between these lines and the hyperbola. But anyway, if you do this based on the diagram that I have seen, this distance over here is called b. And of course you know that this axis is primarily called the conjugate axis. the conjugate axis. Now, and you know that the relationship between B and C and A is B is equal to the square root of C squared minus A squared. That basically, that is how you can find out what the length of this line is. This line segment is. Now, if you basically, now the length of this, now basically as a definition, you can basically do the same thing over here and do the same thing over here, and this distance would also be B. That means that this distance over here is actually I'm losing my voice. This distance over here is 2B, which is, well, by definition is called the length of the conjugate axis. So now what that means is that the length of the conjugate axis is equal to 2B. So this means that 2B is equal to 24, which means that B is equal to 12. B is equal to 12. Now, if B is equal to 12 and C is equal to 13, because you know that your foci are at a distance C from the center. So your C is equal to 13, and you can see that this point is basically along the basically 0 and along the y-axis. This point is along the y-axis, which in turn means that the transverse axis is along the y-axis. So since that is the case, the equation of this hyperbola becomes y squared by a squared minus x squared by b squared is equal to 1. Now I have my C over here and B over here. So basically I need to calculate A over here. So I can use this equation, write this as the square root of C squared minus A squared. And so what that means is that B squared is equal to C squared minus A squared. And what that means is that, take this to the other side, A squared is equal to C squared minus B squared. And so A squared is equal to C squared, which is 169, minus B squared, which is 144, which is equal to 25. So that means that A squared is equal to 25. That is A squared. So then over here I can write y squared divided by 25 minus x squared divided by b squared, which is 144, is equal to 1. So it's easy to you just need to just simply analyze the situation a little bit. And it was number 11. 2544 is equal to 1. You just need to analyze the situation a little bit, and then of course use all the definitions required in this situation, and then solve the problem. Otherwise it's not complicated at all. Really, anything logical is not complicated. Anything logical is not complicated as long as you know all the facts that you need to know, and then just use the facts to analyze the situation and come up with some logical answer. That's basically every possible logical situation is. Of course, some situations you do need you do need some more time in order to analyze the situation, but otherwise it's not really complicated. Okay, so let's go and do another one of these examples. 295. So question number, for example, number 12, for example. Let's do number 12 this time. Okay, so the next question that we have is basically, we had the lattice rectum. So this question is a little bit different, meaning that for example, let's say that your foci are at plus or minus 3 times square root of 5, comma 0, and the lattice rectum and the length of the lattice rectum is 8 units. So the length of the lattice rectum, so you know that the length of the lattice rectum is basically 2 times b squared over a, and if that's equal to 8 units, that means that this is 4, and so what that means is that b squared by a is equal to 4. So that's one basically thing that we get here. And you know that your foci are at a distance a away from the center. So that means that this tells me that a is equal to 3 times the square root of 5. So I can write this equation based on this. I can write this equation b squared over 3 times the square root of 5 is equal to 4. That means that b squared is equal to 12 times square root of 5. And so if I take the square root of both sides of this equation, I will get basically, taking the square root of both sides of this equation, I get the square root of b squared is equal to the square root of 12 square root of 5. And so what that means is that basically now, in order to simplify this, you need to be a little bit careful here. Of course, you know that your b is basically is a positive value, since b is basically a length over here. So then you can basically take this as basically b is equal to the square root of 12 square root of 5. 12 square root of 5. That's possible. But normally, if b was just a general variable over here, you would need to write this as basically the absolute value of b is equal to the square root of 12 square root of 5, and then basically b would be equal to plus or minus the square root of 12 square root of 5. Now over here you get basically two values, a negative value and then a positive value, but of course over here the negative value is of no use, so you just don't do it. And the reason why you have to do this, why you must do this, is actually something that we talked about in the previous videos, meaning that but of course I can talk about it over here as well. Meaning that let's say that you have, for example, 9 let's say that I have some equation over here, for example, b squared is equal to 9. So if I basically, the two values that I can see right now that satisfy this equation are basically, if if I take b is equal to 3, that gives me basically, that gives me 3 squared is equal to 9, which is true. And if I take b is equal to negative 3, that gives me negative 3 whole squared is equal to 9, which is also true. So the solution set of this equation is negative 3 and positive 3. That's the solution set of this equation. That means that both of these values actually do satisfy this equation. Now, the same equation that, let me just first finish this thing over here, and then we will go back to the rest of the things. So over here we said that basically our b is equal to the square root of 12 square root of 5. Now let's suppose that I have this equation over here, b squared is equal to 9, and I want to find out what b is. So what I need to do is take the square root of both sides of this equation in order to get rid of the second power of b here, because I want to get to b. So the square root of b squared is equal to the square root of 9. And so if I just simplify the square root function with the second power of b, I'd get b is equal to 3. Well, this is correct, but not complete, meaning that negative 3 was also a solution here, and we actually tested and saw that negative 3 actually did satisfy the equation as well. So negative 3 is also there, but somehow through what we did, we missed negative 3 here. So then what I need to do, since again both negative 3 and positive 3 can actually satisfy this equation, so when I want to, meaning that b could have been any value, either negative 3 or positive 3, and if you basically raise any of these numbers to the second power, you'll get a 9. So then when I want to basically simplify this equation, in order to not miss the negative part, what I need to do is that I need to write this as the absolute value of b. The absolute value of b is equal to the square root of 9 is equal to 3. And now basically you know that if you want to basically solve this equation, this is basically b is equal to plus or minus 3, which is basically your solution set over here. So with basically using the same logic, of course you have to do the same thing over here, meaning that you have b squared is equal to 12 square root of 5. Now if I take the square root of b squared, I have to take the square root of the other side of the equation as well. And so using the same logic, I write this as the absolute value of b is equal to basically, well, the square root of 12 square root of 5. You cannot of course simplify it this way, so I just write it as square root of 12 square root of 5. Doesn't matter really what it is. And now what this means is that your b is equal to plus or minus the square root of 12 the square root of 5, and that is the solution set. That means that your b is basically these two values, and these two values would actually satisfy this equation. But now you can see that over here, basically since b is just a distance, of course it's supposed to be a positive value, so of course the negative side is not acceptable. So in such cases where the negative side is not important or acceptable, then of course you can simplify the square root of b squared as simply b. But otherwise, generally you have to simplify square root of b squared as absolute value of b, not just simply b. You need to be careful about that. So what that means is that now basically my b is equal to the square root of 12 square root of 5. And I suppose I know my a over here is this thing over here. but well, we really did not need to do this thing over here, because we in the equation we have a squared and b squared, but this was basically actually not very, I mean, it was a good coincidence and also a good mistake of mine that I went through this part over here. And these are the little important things that there are in mathematics. You do need to know them. So now over here you can see that your foci are at these 2 points. These are actually 2 points over here, right? Are at these 2 points, and the y coordinate of the point in both cases are 0. So if the y coordinate is 0, you're along the x-axis. So since the foci is along the x-axis, that means that the transverse axis is actually along the x-axis. And since that is the case, I write the equation of the line as x squared by a squared minus y squared by b squared is equal to 1. And now I have the value of a squared, b squared, so I write x squared by a squared is equal to basically 9 times 5 is equal to 45. 45 minus y squared over basically 12 square root of 5. 12 square root of 5 is equal to 1. That is the value of your that is the equation of the line, which is number 12. And they have simplified this to 25 and 20. I suppose there is some way to do that. 9 times 5. I don't know really if my answer most probably is not wrong, but I can actually test it. I can test it, so let me go and do the graph over here. So if I write basically the same equation that I have over here, I enter it in the x squared. So you have x squared over 45 minus y squared over 12 square root of 5. That's QRT of 5 is equal to 1, and that gives me this thing over here. That gives me this conic section over here. Now if I enter the answer that they have written in the book, it's x squared divided by 25 minus y squared divided by 20 is equal to 1, which is not the same thing. X squared by 25 minus y squared by 20 is equal to 1. Okay, so there seems to be something wrong with my answer here. Okay, so let's see what we have done wrong, if at all that is the case. So basically your foci, that is C. Oh, okay, so this is C, and now, okay, that's the mistake that I've made over here. So you know that your foci are at the distance C away from the center. So that means that C is actually equal to 3 times the square root of 5, and not that. So all of this is wrong, but of course I'm not going to erase this part of the video. I could do that, but I want those parts to be in, so that you know basically about the equations that I talked about. So basically we have now this equation over here. We said that the length of the lattice rectum is 8 units. So that means that 2b squared by a is equal to 8. Simplify these two, you will get b squared by a is equal to 4. And c is equal to 3 square root of 5. Now to calculate, you can calculate using c. Basically you know that b is equal to the square root of c squared minus a squared. The square root of c squared minus a squared. So that means that b squared is equal to c squared minus a squared, and c is equal to, basically c is equal to b squared plus a squared. Actually c squared is equal to b squared plus a squared. And so since basically now over here, based on this, you can say that c squared is equal to basically 9 times 5 is equal to 45. 9 times 5 is equal to 45, and 45 is equal to a squared plus b squared. So, and c squared over here is a squared plus b squared, so therefore you can write a squared plus b squared is equal to 45. Now, if a squared plus b squared is equal to 45, so then over here I can write b squared as b squared is equal to 45 minus a squared, and I can put this over here. So I have b squared, which is 45 minus a squared, over a is equal to 4. Now I can simply solve this equation. So that means that 45 minus a squared plus 4 is equal to 4a, or negative a squared negative 4a plus 45 is equal to 0, or a squared plus 4a minus 45 is equal to 0. And 45 is 9 times 5. So if you write basically 45 9 times 5, and 9 minus 5 is equal to 4, 9 times negative 5 is equal to negative 45. So I can write this equation as a squared plus 9a minus 5a minus 45 is equal to 0. And so I can, for example, take an a out from these two terms, write this as a plus 9, a squared plus 9, and negative 5 out from these two terms, a plus 9 is equal to 0, and then take a plus 9 out, and write this as a minus 5 is equal to 0. So that means that either a plus 9 is equal to 0, or a minus 5 is equal to 0. This gives a is equal to negative 9, and this gives a is equal to 5. This is not acceptable because it's a negative number, and so I take a as positive 5. Now if a is equal to positive 5, what we had over here is there was some equation over here. For example, b squared by a is equal to 4, and so a is equal to 5, so I can write b squared by 5 is equal to 4. That means that b squared is equal to 20, and b is equal to basically to plus or minus the square root of 20, and you can see that I did the same thing over here, meaning that when I have b squared is equal to, for example, 20, I take the square root of both sides of this equation. The square root of b squared is equal to the square root of 20, and to simplify this expression now, I write this as the absolute value of b. and I write here, well, the square root of 20. I'm not going to simplify it right now. And so this gives me b is equal to plus or minus the square root of 20. But of course over here, since b is just a distance, the negative side is not acceptable, so you can write b is equal to square root of 20. Now, so a is equal to 5, b is equal to square root of 20. For the reasons that we said that we talked about before, the equation of the line is in this form. So I can write x squared by a squared, which is 25, minus y squared by b squared, which is 20. Square root of 20 all squared is 20, is equal to 1, and that is the right equation for the line. And that is basically 25 x squared by 25 minus y squared by 20 is equal to 1. So that was number 12. So as you can see, there is a point, there is actually a point in each and every of these exercises. You really don't want to miss them. Okay, so the next one is, so for example, your foci at, suppose that your foci at plus or minus 4, 0. These are your foci, and the lattice rectum is the length of the lattice rectum is basically 12 units. These are essentially all the different ways of thinking about, not of course not all the different ways, but some ways to think about these hyperbolas. And when you basically while you're solving the problem, you have to think basically about those details in that space, basically in the way that you think about them, and that basically helps you to essentially kind of solidify those links that I talked about when I was talking about learning. So when you learn some concept, all the different basically links that you basically, there are different links that you create between the different facts, basically. For example, something like this in many different ways. Suppose that these are the different facts that you know about the concept, and these facts are basically connected to one another in a certain way, in a certain logical way. Now, when you learn some concept like this, suppose that this is a concept and you learn it. Let's say that, for example, some concept in mathematics, for example, hyperbolas. Now, when you solve these problems, these connections are basically made stronger and stronger as you basically think about that concept in different configurations. For example, you want to get here and you are at here, and so you have to start and get, for example, go along this route or go along this route to get here. And then once you do that, these connections are basically made stronger and solidified, and then that once you've done this enough, then you can say that you have understood something, or you have learned that properly, or something like that. So basically, for the same reason, solving exercises is in mathematics, in physics, in chemistry, in in electronics, that is basically crucially important, very, very important. So let's say that the foci are at these 2 points, And since the x coordinate of these points are basically negative, positive, and negative 4, and the y coordinate is at 0, what that means is that basically the point is along, so the foci are along the x-axis, So since the foci are along the x-axis, what that means is that your transverse axis is along the x-axis, and so what that means is that then you can write the equation as x squared by a squared plus y squared by b squared, and of course this is negative. X squared by a squared minus y squared by b squared is equal to 1. Now, since the foci are at a distance c away from the center, so this number tells me that c is equal to 4. And since the length of the lattice rectum is 12 units, the lattice rectum, the equation for the lattice rectum is 2b squared divided by 8, and that is equal to 12. So 2 and 6, that means that b squared is equal to b squared by a is equal to 6. Now, using this equation over here, we said that b is equal to the square root of c squared minus a squared. And of course you know that then based on this b squared is equal to c squared minus a squared. Or I have my c over here, so I can write b squared is equal to 16 minus a squared. And so a squared plus b squared is equal to 16. And then based on this you can say that b squared is equal to what? 16 minus a squared is more than enough here. So now in this equation, b squared by a is equal to 6. Instead of b squared, I can write 16 minus a squared. I can write 16 minus a squared divided by a is equal to 6. That means that 16 minus a squared is equal to 6a. That means that negative a squared, negative 6a plus 16 is equal to 0. And that means that a squared plus 6a minus 16 is equal to 0. Now to factorize this equation, what you can do is that since basically over here you have this number over here, this constant is 16. 16 is basically the same thing as 2 times 8. So 8 times negative 2 is equal to negative 16, and 8 minus 2 is equal to 6. So I can use these two numbers to factorize this equation. So I can write a squared minus 2a plus 8a minus 16 is equal to 0. So I write these two numbers to rewrite this term over here. I write it as 8a minus 2a, which is equal to 6a. And I have not changed anything else in the equation. And so now between these two terms I can take an a out, a minus 2. Between these two terms I can take an 8 out, a minus 2 is equal to 0. Between this term and this term I can take a minus 2 out, and then that gives me a minus 2 times a minus 8 is equal to 0. And then that means that either a minus 2 is equal to 0 or a minus 8 is equal to 0 for this whole equation to be equal to 0. and that gives me is equal to 2, and that gives me is equal to 8. So now I have two values for A. So now basically if B squared is equal to this equation over here, let's for example take this equation. If you get basically two cases or two equations. So if A is equal to 2, then B squared is equal to basically 16 minus A squared, which is equal to 16 minus 4, which is equal to 12. So B squared is equal to 12, and that means that B is equal to plus or minus the square root of 12, which I take as B is equal to positive square root of 12, because B is a distance. So A is equal to 2, B is equal to square root of 12. That is one case. And alternatively, if A is equal to 8, then the same equation, B squared is equal to 16 minus 64. 16 minus 64. And that gives me some answer which is not acceptable. This is a negative value. This is not a, B would not be real then. So you see over here, if I write B squared is equal to 16 minus 64. So 64 minus 16 is equal to, this is a 5, this is a 14. That gives me 8 and 48. So B squared is equal to negative 48. Now B is a number that if you raise it to the second power, basically the result, whatever you get, is a negative number. And this number, such a number, any number in the set of real numbers, any number, if you raise it to the second power, you're going to get a positive number. Meaning that, for example, let's say that you have for example a 3. If you write 3 squared, it's going to be equal to positive 9. If you have negative 3 and raise it to the second power, it's going to give you a positive 9. And any other number in the set of real numbers, if you try, when you square it, you will get a positive number. It's not possible that you can get a negative. That means that the solution over here cannot be found in the set of real numbers. You have to go into the set of imaginary numbers, meaning that you can write this as basically the absolute value of B is equal to basically plus or minus is equal to the square root of negative 48. And 48, of course, is equal to 6 times 8. 6 times 8 is equal to 48. And, well, you cannot 6 times 8. So let me see. The square root of, let's take the 6 times 8. And let's prime factorize it. 48, 2 times 24, 2 times 12, 2 times 6, 2 times 3, and that's it. So you have, so that would be, so you see that 48 is the same thing as 2 raised to the power 4, 2 raised to the power 4 times 3. That means that the square root of 48 is the square root of 2 raised to the power 4 times 3. Now the square root of 2 raised to the power 4 is equal to 2 raised to the power 2, or 4. 4 square root of 3. So that means that the square root of 48 is equal to 4 times square root of 3. Okay, then we can keep this over here for now. You are going to need that. So now what this means is that to solve this equation, you need to write B as plus or minus square root of negative 48. And of course this plus or minus is different from this negative over here. Now, you can write this as b is equal to plus or minus the square root of negative 1 times the square root of, let me write it this way. You can write this as the square root of negative 1 times 48. Now, you can write this as plus or minus the square root of negative 1 times the square root of 48. Now, the square root of negative 1, by definition, is equal to I, and that's the unit imaginary number. So then I can write this as plus or minus I times the square root of 48 is 4 times the square root of 3. 4 times the square root of 3. So you can write this as basically plus or minus 4 square root of 3i. But basically in any case, whether the number is positive or negative, the number is no real number, and it's not going to be an acceptable solution for us in this case. So I'm going to reject both the answers. And I'm just going to go with this answer over here with these two values for A and B. So over here we said that x squared over a squared minus y squared by b squared is equal to 1. So I can write x squared by a squared minus y squared by b squared is equal to 1. And what that means is that then basically if I can write x squared by 4 minus y squared by 12 is equal to 1, and that is the answer to your equation. So question number 13 is x squared by 4 minus y squared by 12 is equal to 1. Okay, we have two more problems over here that we will do in the next video. See you in the next video.